Hello everyone, this is the audio visualized recording for the organic chemistry. My topic is fats, oils, and detergents. Introduction. Oil and fats are the widely distributed in nature both in animals and plant kingdoms. In animals, they are present under the skin in the muscles, but in plant they are mainly found in the seeds. Some important example of the fat are butter in mussels, but in the example of main found in the seeds. Some important example of fat are butter, lard, tallow, beef, etc. While groundnut oil, condensed oil, olive oil, palm oil, coconut oil, sunflower oil, soybean oil, linseed oil, sesame oil are important example of vegetable oil. For fats and the oils are one of the three major constituents of our food. The other two being carbohydrate and proteins. In fact, fats and oils serve as energy reservoirs for the animals. In human beings, only a few hundred grams of glycogen can be restored. Fats and oils are one of the three major constituents of food, the other two being carbohydrate and protein. In fact, fat and oils serve as the reservoir in the animals. In human beings, only a few hundred grams of glycogen can be stored, which can barely supply the food's energy needs for our about 12 to 18 hours. In contrast, large amount of fats can be stored which supply the blood energy needs for the about 8 weeks. Beside this, oils and fats and serve as raw material for a name of industries such as soap, paint, varnishes, vanaspati ghee, etc. Natural fats. The fat obtained from animal source such as butter, lard from hogs, and tallow from sheep, goats, etc. are called natural fats. This name is simply given to differentiate these fats from these fat are obtained by hydrogenation of oils, edible and non-edible oils. Oils such as groundnut, sunflower, soybean, rapeseed, mustard, olive, sesame, which are used for cooking purpose that are edible oils. While oils such as cottonseed oil, linseed oil, castor oil, neem oil, which are usually in soap, paints, varnishes, lacquer industries, are called non-edible or industrial oils. On the basis of iron values of oil have been classifying as drying, semi-drying, and non-drying oils. Industrial oil may include essential oil or mineral oil. Essential oils such as rose oil, jasmine oil, lavender oil, alphatic oil, peppermint oil, etc. are volatile oils isolated from the plants. Essential oil may be hydrocarbon, alcohol, aldehyde, ketones, ester. And for example, peppermint contain methanol and its chief constituent. Essential oil are mainly used in perfumes, cosmetics, and in pharmaceutical products. On the other hand, mineral oil is a mixture of saturated and unsaturated hydrocarbon and not ester of triglycerides. They cannot be saponified. They are called simply because of the physical appearance. They are non-edible or are mainly used as fuels. Triglycerides composition of the oil and fats. As stated, fats and oils are triesters of glycerol with higher aliphatic monocarboxylic acid. In the other words, there are triglycerols and are commonly used as glycerides. Fatty acid. With only a few exceptions, all the monocarboxylic acid isolated from the fats and all are straight chain compound containing 3 to 18 carbon atoms. Further, with the exception of only C3 and C5 acid, all the other acids contain and found in fats and oil contain even number of carbon atoms, the chief saturated fatty acid present in oils and fats. Besides saturated fatty acid, unsaturated fatty acid containing one or more double bonds and cis orientation may also be present in oil and fats. Now the classification of glycerides. The three fatty acid in glycerides may be same or different. Therefore, glycerides are classified as simply or mixed glycerides according to they have the same different acid residue. For example, simple glyceride, mixed glyceride. Glycerides are further classified into saturated and unsaturated glycerides according to the contained saturated fatty acid residue or unsaturated fatty acid residue. That is tristearine and triiolane. Both simple and mixed glycerides are found in natural oils and fats. In fact, oil and fats are complex mixture of mixed glycerides along with the same amount of simple glycerides. The main difference between oils and fats in the proportion of the saturated and unsaturated glyceride, the triglyceride with higher proportion of Saturated acid residue such as a palmitic acid, stearic acid, solid are the ordinary temperature are called fats, while those in the higher proportion in unsaturated acid residue such as oleic acid and linoleic acid are liquid at ordinary temperature are called oils. Melting point of glycerides. As stated above, fatty acid have one or more double bond having less stable cis stereochemistry. For example, oleic acid C17H33COOH has one cis double bond at C9. Linoleic acid C17H31COOH has two double bond at C9 and C12, while linoleic acid C7H29COOH has three cis double bonds at C9, C12, and C15 positions. These cis double bonds are vital biological importance in solid state. The molecules of the saturated fatty acid fit closely in the crystal lattice due to their zigzag tetrahedral structure. On the other hand, such unsaturated fatty acid have been bent to a double bond and hence does not fit closely, therefore lowering their melting points. Chemical properties. Fats and oils being triesters of glycerol show all the reaction of simple esters in case the glycerides contain unsaturated fatty acid residue. They also show the usual addition and oxidation reaction of alkenes. Some important reaction of the fats and oils are hydrolysis. The fats and oil are readily hydrolyzed by treatment with superheated steam and minerals, acid or alkalis. Hydrolyzed by superheated steam and minerals acid give a mixture of fatty acid and glycerol. However, when the hydrolysis is carried out by alkalis, glycerol and salt of fatty acid are formed. Since the salt of higher fatty acid thus formed are used for soaps, the alkaline hydrolysis is commonly called saponification. Now the second term is hydrogenation. Oils which contain a higher proportion of unsaturated glycerides add on hydrogen is in the presence of fine divided nickel as a catalyst in the solid form. For example, triiodine plus 3 hydrogen in the presence of nickel and 453 Kelvin temperature and 20 to 40 Pascal pressure changes into tristyrene whose melting point is 334 Kelvin. This process is called hydrogenation of hardening of oils. It is similar to the catalytic hydrogen of the alkene and involves the reduction of double bond present in unsaturated glyceride to form saturated. This process is extensively used for the manufacture of vanaspati ghee from the groundnut, peanuts, sunflower and the edible oils. Hydrogenation is never carried out completion but it stopped soon as fast of consistency comparable to ghee is obtained. The completely hydrogenation fats are too hard to be useful as kitchen shortening. The main advantages of the hydrogenation is that compared to oils, fats have better storage qualities and does not become rancid easily. Hydrolysis conversion to alcohols. Fats and oil on treatment with hydrogen at higher temperature and pressure in the presence of copper chromate as catalyst undergo reactive cleavage to form glycerol and long chain aliphatic alcohols are formed. The splitting of fat or an oil to glycerol and a higher long chain alcohol by hydrogen is called hydrogenolysis. The long chain alcohols thus produced are used for manufacture of synthetic detergents. Transesterification. Fats and oils can be converted into simple esters of carboxylic acid such as methyl ethyl esters by transesterification. It involves the treatment of a fat or an oil with a large excess of a suitable alcohol in the presence of acetic or basic catalyst. The process of transesterification is quite useful for large-scale preparation of long-chain fatty acid and long-chain primary alcohol of high purity. For this purpose, the mixture of methyl ester obtained by transesterification is subjected to fractional distillation to separate the individual esters. These upon hydrolysis yield fatty acid of high purity. Alternatively, the individual methyl ester reduced to get long chain primary alcohol. Addition of halogen. Like alkene, unsaturated glycerides add halogen across the double bond to form addition products. The addition of iodine is usually carried out by the treating the fat or the oil with iodine in the presence of mercury chloride as a catalyst. Since the amount of iodine used in proportional to the number of double bond present, therefore this reaction is called determination of extent of unsaturation is given in fat or the oil. Now the sixth point is rancidity. When fats and oil are exposed to the warm air and the moisture of the long term, they develop a disagreeable smell and taste. This process is called rancidity and involves the hydrolysis of esters to produce rancidity. The double bond to form short chain acid and aldehyde. These short acid and aldehyde are volatile and offensive smells. Therefore, they impact unpleasant odor to oils and fats. Rancidity is following two types: hydrolytic rancidity and oxidative rancidity. Hydrolytic rancidity. This type of rancidity is caused by the liberation of lower fatty acid by hydrolysis of triglyceride. For example, when butter is exposed to warm air and moisture, the hydrolysis of the glycerides in butter yield butyric acid and low volatile acidic with unpleasant odor. And the oxidative rancidity. This type of rancidity is caused by the oxidative of the unsaturated triglyceride by air to form short acid and aldehyde having unpleasant smell. It is believed that the ester linkage are hydrolyzed to yield unsaturated acid which undergo oxidation at the site of double bond to produce short chain acid and aldehydes. Analysis of fats and oil. There are the three methods or more. There are some methods for the analysis of fats and oil. First, acid value. It is defined as the number of milligram of potassium hydroxide required to neutralize the free fatty acid present in 1 gram of water or oil. Saponification value. It is defined as the number of milligram of potassium hydroxide required to completely saponify 1 gram of fat or oil. And the third is iodine value. It is defined as the number of gram of iodine that will combine with 100 gram of fat or oil. Now, iodine value may be determined by two methods: Hubble method and Wiggs method. In this method, a solution of known height if fat or oil in CCl4 carbon tetrachloride is allowed to react with the known excess of standard solution of iodine ethanol in presence of mercury chloride as catalyst, the unreacted iodine is determined by the titrating it against standard sodium thiosulfate solution using starch as an indicator. Wiggs method. In this method, a solution of more reactive iodine monochloride in glacial acetic acid is used for the iodic and mercuric chloride. Now the fourth method is Richter-Meisel method. It is defined as the number of milliliters of 0.1 normal KOH required to neutralize the steam volatile fatty acid obtained by completely hydrolyzed of 5 gram of fat or oil. Industrial oil or vegetable origin drying oils. Certain oils such as linseed oil, tung oil, china wood oil, perilla oil, when exposed to air in the thin layer, form hard and tough water soluble solids. This process is called drying, and the such oils are called drying oils. Oil like olive oil, groundnut oil, which do not dry to expose to air, are non drying oils. Soaps. Soaps like substance like soaps and synthetic detergents which concentrate at the surface of the solution or interface from the surface films reduce surface tension of the solution and help in removing dirt and dust by emulsifying the grease are called surfacing active agents and surfactants. The molecule and surfactant contains the two characteristic soap which is soluble hydrophilic and which is oil soluble lyophilic and lyophilic. Soaps are the sodium and potassium salt of higher fatty acids such as palmitic acid C15H31 COOH and stearic acid C17H35 COOH and oilic acid C17H33 COOH. The fats and oil commonly used for soap manufacture are called tallow, hard olive oil, linseed oil, mahua oil, rapeseed oil, coconut oil, and palm oil. Sodium soaps are generally hard and hence hard soaps. They are used for washing of clothes. Potassium soaps, on the other hand, are more expensive and reduce the softer leather and hence they are called soft soaps. They are used for making shaving cream, shampoos, liquid soaps, etc. Soaps are 100% biodegradable microorganism present in sewage water can completely oxidize soap in CO2. As a result, it does not create any pollution problems. However, soap has two disadvantages also. Soap cannot be used in hot water since calcium and magnesium ion present in hot water produce curdy white precipitate of calcium and magnesium. Soaps can not be used in acidic solutions. Precipitate of the insoluble free fatty acid which adhere to the fabric and thus block the ability of a soap to remove the oil and grease from the fabric. Now the synthetic detergents. This the calcium and the magnesium salt of detergents like sodium and potassium salt are soluble in water, hence acidic solution. However, synthetic detergents have one disadvantage: unlike soap, they are not completely biodegradable and hence cause water pollution. There are different three types of detergents: anionic detergents, cationic detergents, and non-ionic detergents. These are the three types of detergents. Now we will discuss about detergent pollution. Detergent having branched chain hydrocarbon chain cause pollution in river and other waterways. These reason being the side chain stop bacteria from attacking and breaking the chains. These result in slow degradation of detergent molecule leading to the accumulation since unbranched chains are more prone to attack by bacteria and therefore in a most of detergent used these days. Now the cleaning action of a soap. All the soap and the detergents containing two characteristics group that is hydrophilic and hydrophobic. As a result, one end of the molecule of a soap detergent leads to it going oil phase, another wants to go into the water phase. The net result that the material concentrate at the surface of the solution over interface. The dirt is generally held to a dirty surface by a thin film of an oil and a grease. When the dirty surface is treated with the soap solution, the nonpolar hydrocarbon chain of the soap or detergent dissolve in oil or grease by the carboxylic group of the soap or the sulfonate group of synthetic detergent held by surrounding water. This lowers the surface tension between water and grease. As a result, a stable emulsion of oil in water is formed. When the surface or the cloth is mechanically scrubbed, the loosened dirt particles are absorbed by colloidal soap or detergent particles and ultimately washed away. Thank you.